Polynomial equality example 2. So we're given that x minus 2 is a factor of this polynomial here. We want to find the value of a and the other factors of p of x. Now, x minus 2 is a factor tells us that x equals 2 is a 0. So p of 2 would be equal to 8 plus 4a minus 4, take away 24, that must be equal to 0. So that gives me 4a take away 20 is equal to 0. So 4a equals 20, a is equal to 5. And that tells us that the polynomial is x cubed plus 5x squared minus 2x minus 24. Now we want to find the other factors of this. Now we could use polynomial division and divide this by the x minus 2, but I find that quite a long way of going about things. So I tend to use something called inspection, which is if I know that x minus 2 is a factor, the other factor to get a cubic must be a quadratic. Not only that, this term is x cubed, so we must start with x squared, because x times x squared gives me x cubed. We've got a negative 24 here and negative 2 there, so we must have a plus 12 at the end of the bracket. So the only one we're not sure about is the middle term. And to get that, perhaps I should call it b, since we already used a over there. To get the value of b here, then I just need to compare a coefficient. So let's compare, say, x squareds. So what would give me x squareds from here? This will. So I've got negative 2x squared. And this will. So I've got bx squareds. And that must be the same as the x squareds in here. So I've got negative 2 add b is equal to 5, which tells me that b is equal to 7. So our p of x is x minus 2, x squared plus 7x plus 12, and you shouldn't need to look for too long. The quadratic factor is not guaranteed to factorize, but this one does, and it's just an x plus 3 and x plus 4.